10 of the strangest ways the universe really works. Close your eyes for a moment and imagine this. A universe where planets wander through eternal darkness with no sun, stars die and then somehow explode twice, and entire galaxies appear to have been dead for billions of years, just quietly drifting through the cosmos like ghosts. This isn't science fiction. These are real features of the universe we live in, gradually uncovered by telescopes and patient astronomers over decades. In this video, we're going to explore 10 of the strangest ways the universe really works. From lonely planets raised without a star, to the possibility that the entire cosmos itself might be spinning like a colossal carnival ride. So take a slow breath, settle in, and let your mind drift outward. Let's begin our journey with some of the universe's most unusual children. 10. Rogue planets, worlds without a sun. When you picture a planet, your mind likely conjures a familiar scene, a world tethered by gravity to a parent star, tracing a predictable path through the cosmos. You probably imagine it orbiting a warm, familiar star, bathed in the life-giving light that drives seasons, weather, and perhaps even biology itself, much like Earth orbits the Sun. This model of a solar system, a star with its family of planets, is the foundation of our cosmic neighborhood. But out in the vast, silent dark between the stars, in the immense gulfs that separate one solar system from the next, a different kind of world exists. Here there may be more planets that have no star at all. Astronomers call them rogue planets, though they are also known as interstellar, free-floating, or orphan planets. These are worlds that drift through space on their own, cosmic wanderers on a solitary journey through the galaxy, not bound to any solar system. How does a planet find itself so utterly alone? Some were likely kicked out of their original homes during the chaotic early days of planetary formation. Imagine a violent gravitational tug-of-war between giant planets, where a smaller world is caught in the crossfire and flung out into interstellar space like a stone from a slingshot. Others may have formed in isolation from the very beginning, condensing from small, dense clouds of gas and dust that were simply not massive enough to ignite into a star. Because they emit no light of their own, these worlds are incredibly difficult to detect. Yet, observations suggest there could be trillions of these orphaned worlds just in our galaxy alone, a staggering number. In fact, they could be the most common type of planet in the cosmos, possibly outnumbering the stars themselves. To grasp the nature of such a world, imagine Earth suddenly and violently flung into deep space. The sun would shrink to a brilliant star, then fade into the background noise of the Milky Way. Its skies would become permanently black, its oceans freezing over, its continents buried in a deepening layer of ice, a world of eternal night and profound cold. And yet these worlds might not be entirely lifeless. They are not inert balls of ice. Far beneath the frozen surfaces, a hidden source of energy could be at play. For larger planets, tidal heating from an internal core, or the presence of a large moon, or the lingering radioactive decay of heavy elements within its rocky mantle, could generate enough warmth to keep hidden oceans liquid and warm. The thick ice shell above would act as a perfect insulator, protecting this inner world from the cold of space. Life, if it existed there, would be entirely independent of a star. It would never know starlight, photosynthesis, or the rhythm of day and night, only the faint glow of geothermal warmth from hydrothermal vents, much like the ecosystems found in the deepest trenches of Earth's own oceans. Some evidence even hints that a few rogue planets are not entirely alone on their journey. They might carry dusty disks around them, or even a retinue of their own moons, like the building blocks of miniature solar systems without a sun. In other words, these lonely travelers may host their own complex systems. It seems that even in the loneliest places in the galaxy, in the endless night between the stars, the universe still quietly experiments with making new worlds. 9. A galaxy that died too early. In the grand cosmic ballet, not all dancers finish their performance. Some leave the stage long before the music ends, their light dimming into a quiet, premature twilight. This is the story of those galaxies, the ones that fell silent when they should have been at their most vibrant. We often imagine galaxies as vast cosmic cities of stars, busy, bright, and bustling with new suns being born all the time. Their spiral arms are like sprawling downtown districts illuminated by the brilliant blue light of young, massive stars. Within them, vast clouds of gas and dust, the stellar nurseries, serve as the raw material for creation, constantly building new generations of suns and planets. This is the normal, expected life cycle of a galaxy, a continuous self-sustaining engine of creation. But some galaxies seem to have given up on this cycle, shutting down star formation long before they were expected to. Astronomers call this process quenching, a gentle but irreversible halt to the creative energies of the cosmos. They have discovered galaxies so old and so quiet that they appear to have been dead for billions of years. That means for most of cosmic history, they simply stopped making new stars. The stellar nurseries ran dry. The vibrant blue glow of youth faded, replaced by the dim, ruddy light of an aging population. No new suns, no fresh solar systems, just a silent metropolis of old, cool red giant stars, all slowly, gracefully burning out. To understand why this happens, we must first look at what keeps a galaxy alive. Galaxies normally stay active by feeding on vast intergalactic clouds of cold hydrogen gas. This cosmic fuel flows in from the space between galaxies, replenishing the reserves. Once inside, gravity takes over, compressing that gas into dense pockets until it ignites into brilliant newborn stars. It's a delicate balance of supply and demand. But in some cases, this life-giving process is violently interrupted. One culprit is the environment. As a galaxy moves through a dense cluster, the immense pressure of the surrounding hot gas can strip its fuel away, a process known as ram pressure stripping. Another cause can come from within. The supermassive black hole at the galaxy's core can erupt with powerful jets, heating the available gas so much that it can no longer cool down and collapse into stars. Whatever the cause, the result is the same. The galaxy becomes a kind of cosmic fossil, a place frozen in time, preserving a snapshot of the universe as it was billions of years ago. It is a relic, a silent monument to a life that ended too soon. What makes this especially strange is how early it seems to have happened in some cases. Using telescopes like Hubble and the James Webb Space Telescope, astronomers have peered back into the cosmic dawn and found galaxies that were already quenched when the universe was only a few billion years old. At that time, we expect the universe to be at its most lively, forming stars at a furious rate for many billions of years to come. Finding these ancient, silent galaxies forces astronomers to rethink how quickly some corners of the universe can mature and grow old. It suggests that the processes that quench star formation can be incredibly efficient and rapid, capable of shutting down a massive galaxy in a cosmically short period. In a way, these dead galaxies are the universe's retired cities, beautiful, quiet, and filled with history, but with their best days behind them. They are powerful evidence that not every region of space shares the same fate or tempo. While some parts of the cosmos are still in their vibrant youth, others have already lived a full life and settled into a long, peaceful retirement. 8. The star that exploded twice. Stars die in spectacular ways. Some quietly fade. Others go out in titanic explosions called supernovae, briefly outshining entire galaxies. But astronomers have found evidence of something even stranger, a star that appears to have exploded twice. The key player here is a white dwarf, the dense Earth-sized core left behind when a sun-like star exhausts its fuel. In some systems, a white dwarf orbits a companion star and slowly steals gas from it, piling that material onto its own surface. In one carefully studied case, astronomers identified what's called a double detonation supernova. First, the stolen gas on the white dwarf's surface ignited, creating a powerful explosion in the outer layers. That blast sent a shockwave inward, triggering a second, deeper detonation in the star's core. To an observer, it's as if the star dies twice in rapid succession, a cosmic 1-2 punch. These violent events help forge heavy elements like iron, which ultimately end up in planets, in magnetic fields, and even in your blood. So, the next time you hear that we are made of star stuff, you might remember that some of that stuff comes from stars that refused to go quietly and instead went out in a double flash of cosmic fireworks. 7. Planets forming in cosmic chaos. We often picture the birth of a solar system as a gentle process, a calm disk of gas and dust slowly settling into tidy orbits. The reality is far more turbulent. High-resolution images from modern telescopes show newborn stars surrounded by swirling disks sculpted by jets, winds, and shockwaves. Some infant stars have been caught at such early stages that we can literally watch the raw ingredients of planets starting to clump together. The scene isn't peaceful. Thin jets of material blast out from the star, wings of gas are pushed away, and streams of molten dust swirl in looping spirals. Within this chaos, tiny grains collide and stick, gradually building up into pebbles, rocks, and eventually entire worlds. This means that the planets we stand on, including Earth, may have been born in a storm, forged in a noisy, violent environment where gravity, radiation, and magnetic fields fought for control. The next time you look at a calm night sky, remember that behind those serene points of light lies a past filled with jets, shocks, and the wild, messy art of planet-making. 6. Hidden black holes in our cosmic backyard. Black holes are famously hard to find. By definition, they don't emit light. We usually detect them by how they affect nearby stars and gas. But astronomers have uncovered supermassive black holes lurking surprisingly close to home, not in our own Milky Way alone, but also in some of our nearest galactic neighbors. These giants sit in the central regions of nearby galaxies, quietly influencing the motion of surrounding stars. They may not always feed in dramatic visible outbursts, but their gravity shapes the heart of those galaxies. This hints that our local patch of the universe may be filled with more massive black holes than we realized, some of them relatively nearby on cosmic scales, and that's only the visible tip of the iceberg. Smaller stellar mass black holes could be scattered throughout our galaxy, some drifting through space with almost no obvious signature at all. The unsettling truth is that the universe may be full of invisible, city-sized regions of warped space-time, waiting to be noticed only when something wanders too close and pays the price. 5. Zombie stars that shred planets. If a star can die and still cause trouble, it might be fair to call it a zombie. White dwarfs, the corpses of sun-like stars, are extremely dense, with gravity strong enough to tear apart anything that strays too close. Astronomers have observed white dwarfs emitting puzzling flares and bursts of high-energy radiation over long periods of time. One compelling explanation is that once giant planets in those systems wandered too close to the star's corpse, the white dwarf's gravity ripped those planets to pieces, forming streams of debris falling onto the stellar surface. Each time chunks of that planetary rubble slam into the white dwarf, they release bursts of energy, like sparks flying from a cosmic grinder. From our vantage point, we see flickers of high-energy light that can continue for decades. This story carries a quiet warning. Our own sun will eventually end its life as a white dwarf. Billions of years from now, any surviving planets could face a similar fate, nudged into lethal orbits and torn apart by the very star that once gave them life. The universe, it seems, doesn't always leave its planets in peace, even long after the lights have gone out. 4. The universe's strange soundtrack. Space is often described as silent because there's no air to carry sound waves. But the universe still has a kind of music, vibrations in gas, plasma, and even in space-time itself. In massive galaxy clusters, astronomers have detected pressure waves rippling through hot gas. like the cosmic equivalent of sound waves in the atmosphere. Some of these waves correspond to notes so deep that a single oscillation would take millions of years to complete. You could never hear them with your ears, but instruments can translate these ripples into audible tones. The result is eerily beautiful. A low, droning hum that reminds us the universe is not static, but constantly shifting, vibrating, and ringing like a gigantic, invisible bell. Even more dramatically, ripples in space-time called gravitational waves have been detected from colliding black holes and neutron stars. These waves stretch and squeeze space itself as they pass through us, carrying information about cataclysmic events from billions of light years away. So while you may not hear it at night, the universe has a soundtrack. You simply need the right instruments and a great deal of patience to listen in. 3. Dark matter, the invisible architect. When you look at a beautiful spiral galaxy, you're only seeing a small fraction of what's really there. Most of the mass holding that galaxy together is invisible. Astronomers call it dark matter, a form of matter that doesn't emit, reflect, or absorb light, yet exerts gravity all the same. We know it exists because galaxies rotate too quickly for their visible stars and gas to stay bound together on their own. Something unseen is adding extra mass. Computer simulations show that dark matter forms vast, web-like structures across the universe, shaping where galaxies can form and how they cluster together. In a sense, dark matter is the scaffolding on which the visible universe is built, and yet we don't know what it is. It might be made of undiscovered particles, or it could hint at a deeper misunderstanding of gravity itself. Despite decades of searching, no one has detected a dark matter particle directly. It's a bit like trying to understand a city by only looking at its streetlights at night. You see the glow, but all the unlit buildings and roads in between remain hidden. Dark matter is the unseen architecture that keeps the cosmic city from flying apart. 2. Dark energy and the runaway universe. For much of the 20th century, astronomers thought the expansion of the universe should be slowing down. After all, gravity pulls things together. But in the late 1990s, they discovered something deeply unsettling. The expansion of the universe is not slowing, it's speeding up. To explain this, scientists invoked a mysterious phenomenon called dark energy. Whatever it is, it seems to act like a kind of negative gravity, pushing space apart faster and faster. Today, many estimates suggest that dark energy makes up the majority of the total energy content of the universe. We don't know what dark energy is, where it comes from, or whether it will remain constant forever. If it continues as it is now, galaxies will drift farther and farther apart, and the night sky of distant future observers will grow emptier and darker. On human timescales, nothing will seem to change. But over billions of years, dark energy quietly rewrites the universe's fate, transforming a relatively crowded cosmos into a lonely, ever-expanding abyss. The strangest part, the very fabric of space appears to be actively doing something, driving the cosmos apart for reasons we don't yet understand. 1. A universe that might be spinning. From our own planet to the most distant stars and galaxies, the cosmos is filled with motion. We see it everywhere. We know that planets spin, a legacy of the swirling disks of gas and dust from which they formed. We know that stars spin, some so fast they bulge at their equators, their shape distorted by immense centrifugal force. And we know that entire galaxies spin, their majestic spiral arms tracing a cosmic dance that takes hundreds of millions of years to complete. This rotation is a fundamental consequence of gravity and the conservation of angular momentum. As vast, diffuse clouds of matter collapse, any tiny, random initial rotation is amplified, just as an ice skater spins faster when they pull their arms in. Rotation is not an exception in the universe, it is the rule. But what if this principle applies not just to the objects of the universe, but to the universe itself? What if the entire fabric of space-time was born spinning as well? This is a profound and unsettling question, because for nearly a century, Our standard model of cosmology has been built on a foundational assumption, the cosmological principle. This principle states that on the largest scales, the universe is the same in all locations and in all directions. It is isotropic. A spinning universe would violate this principle. It would have a preferred direction, a cosmic axis of rotation. And yet, some tantalizing, though highly debated, evidence has emerged. Some observations of very distant galaxies have suggested that an unusually large fraction of them seem to rotate in the same direction. If you were to look out into the cosmos, you would expect to find a perfectly random distribution. Instead of a roughly even mix of clockwise and counterclockwise spins, there may be a subtle preference, a cosmic bias in how things turn. One bold idea is that this pattern could be a faint echo of a primordial rotation, a twist built into space-time itself from the very beginning. If true, it would mean the universe isn't just expanding, as we've known for a century. It might also be slowly spinning as a whole, like an unimaginably vast carousel. Now, it must be said that most cosmologists are quite rightly cautious. The signal is faint and incredibly difficult to measure accurately across billions of light years. There are other possible explanations. Perhaps our telescopes or analytical methods have some hidden systematic bias that we haven't accounted for, or perhaps large-scale structures in the cosmic web, like immense filaments of dark matter, could influence the spin of galaxies in a way that mimics a universal rotation. The data needs to be tested carefully, cross-checked with different instruments and independent teams of scientists. That rigorous process is underway. But even entertaining the idea forces us to rethink the very nature of the Big Bang and cosmic symmetry. It challenges our most basic picture of the universe's origin. Imagine looking up at the night sky and realizing that every star, every galaxy, every particle is part of one grand, slow rotation, a subtle spin that has been in motion since the dawn of time. Whether or not this specific idea survives future scrutiny, it perfectly captures a recurring theme in cosmology. The universe is rarely as simple as we once believed. Each time we build a model that seems elegant and complete, a new observation, a new anomaly, comes along to remind us that there is always more to learn. The cosmos, it seems, delights in surprising us. We've wandered through a universe where planets roam without suns, ghostly galaxies give up on making stars, and dead suns tear apart the worlds that once circled them. We've listened to ripples that act like sound in hot clouds of gas, met the invisible architects of galaxies in dark matter and dark energy, and flirted with the idea that the entire cosmos might be spinning in ways we're only just beginning to suspect. For all our telescopes and equations, one thing is clear. The universe is stranger, more complicated, and more creative than our imaginations alone could ever have invented. If this journey through its weirdest workings has sparked your curiosity, there is so much more to explore. Thank you for traveling with me through the dark and dazzling depths of space. If you enjoyed this calm trip through the cosmos, consider joining me again for more quiet voyages into the mysteries of our universe.